Physics Challenge 2, alternate current. Now we have a capacitor has a leak resistance R. Well, in the real world there is always leak resistance to the capacitor in parallel. It's pretty high, right? And we are going to build up the voltage here by 3 microamp current source. So how long is going to take? So this is not alternate or not DC, it's called transient problem. And transient problem, you end up with solving the differential equation. So you need to know how to solve the differential equations. Those linear differential equations, the typical one you can use is a Laplace transformation, and it's often used in electrical engineering. Okay, so let's look at C, how this work out. Now the current going here is C dV dt, and the current going here is V over R, right? Okay, so total current, which is 3 microamp, is I1 plus I2, which is constant. Okay, so we use I as a constant. So the C dV dt plus V over R equals I. Now we multiply R both together, and this is going to be, say, constant P. Okay, so this is differential equation. We have to solve V, and this is constant. Okay, so you can go through Laplace transformation. If you haven't learned the transformation, I think only way is to just accept the differential equation result. V becomes A e to z negative t over p plus b, and we need to determine A and B. So when t is 0, this is going to be 1, so A plus B equals, well, t is 0, it's going to be voltage is 0, right? And the P is a typical so-called RC constant, is the charging time factor. This kind of typical, let's see, and initially let's see, let's take care of this first. So B equals minus A, so it's going to be A1 minus E negative T over P, right? Okay, so when t is 0, the satisfied equation, it's going to be 0. V is 0. You need one more place to determine the constant A. Let's see how to determine that. When t is, you give infinite time, it's eventually reached to the V voltage, which is this. So this is going to be V0 1 minus E T P. So this is the final voltage, but it's not asking final voltage, it's asking 500 volt. Okay, But final voltage here, if you keep charging the that means you don't charge anymore, because this become exactly same as this leak current. So say this is I, so I equals this leak current V0 over R. So V0 final voltage is going to be RI, assuming this is I. So we fix all the parameter here. Ri 1 minus e to the t and Rc. Okay, now we got all the parameter. So we got I, which is 3 microamp. R is quite large, 2 times 10 to the 8 ohm. Okay, so C equals microfarad, 5 microfarad. We plug in this number, and V is 500. So you need a calculator or probably Excel to solve these nonlinear equations numerically. That means you make a table and increase little by little, go between and determine the t. Okay, so please do that. I'm not sure, I can't do this here on the screen, but you got all the parameters, RC, I, and you have to calculate the t, which is gonna be log, right? So it's 500 divided by Ri, and 1 minus is going to be and take the log, is going to be Rc. So t is going to be Rc. Okay, you have to calculate this. Okay, so you get time. I hope you enjoyed this video. Please check out the video too, and if you like, subscribe.